Welcome to Math Proofs. My name is Adiyoja, and today we're going to be proving two powerhouse trigonometric identities, and that is the expansion of sine A plus B and the expansion of cosine A plus B. And I've listed the expansion below. And an important part of this proof is that it is 100% visual. And because it is visual, it'll help us gauge our intuitive understanding of both of these identities. So let's get right to it. So to start off this proof, I have to draw this triangle, and it's two right triangles. On one triangle, we have an angle of A. It has a 90-degree angle here. And on the other triangle, we have an angle of B, and you see that it also has a 90-degree angle. And the only thing that we need to define before we start going forward and deriving everything is that this length over here, B's hypotenuse, angle B's hypotenuse, is going to be 1. We're going to set that equal to 1. And now we're going to go forward and let's solve for some of these sides. I'm first going to look to the triangle with B, and let's find out what this side over here is. I'm going to call this side C, and I'm going to call this side D. So let's solve for these. And we can basically use our trig knowledge. We know that for C, we know that the cosine of angle B is going to be equal to C over 1. Cosine is equal to adjacent over hypotenuse. This is the adjacent, that's the hypotenuse, so C divided by 1. Well, dividing by 1 really doesn't change the value, so you can almost scratch this out. And you see that C is equal to cosine of B. Cosine of B. Now let's do D. For D, we know we're going to use the sine identity. So that is that sine of B is equal to, well, sine is equal to opposite over adjacent. So it's going to be D over 1. And again, because it's divided by 1, we can basically ignore it. And we know that D is equal to sine of B. Sine of B. Okay, now that we've solved for these two side lengths, we could go ahead and solve for these two side lengths over here. I'm going to call this X. I'm going to call this Y. But there's some more side lengths that we need to solve for first before we can get to any meaningful proof. So I'm going to draw another triangle right here. And it is also going to have a 90-degree angle. And I'm going to draw a final triangle over here. So now you see that everything we've drawn is contained within a rectangle. So now we have a bunch of side lengths, all these outside side lengths. I'm going to call this one L. I'm going to call this one E. This one will be called F. This one will be called G. We have all these side lengths to solve for. So before we solve for any of these side lengths, we need to have angles that we can use. So let's derive those angles. So first, what angle is this going to be? Well, I know that from this line to this line, I have a total of 90 degrees. And I have two angles that I know. I have an A and I have a B. So what angle is missing? This angle, the mystery angle, I'll call it alpha. What angle is missing over here? Well, I can just solve for it using algebra.
I'll subtract A and B from both sides, and I'll get that alpha is equal to 90 minus A minus B.
So this angle right over here is 90 minus A minus B. Now what does this angle have to be then? Well, if this is 90 minus A minus B and this is 90, and these three angles have to add up to 180, we can solve for that again.
So we have 90 minus A minus B plus 90 plus some beta, and those are the three angles inside a triangle, so they sum up to 180. We realize that 90 plus 90 is really 180. Then we know that we have a 180 on both sides, so we can subtract them from both sides. I'm just going to cancel it. And then to solve for B, I have to add A plus B to both sides. So then we get beta is equal to A plus B.
So this angle over here is A plus B. I know this is getting quite tedious, but I want to make sure that I solve every angle for you so you have no doubts. So what is this angle over here going to be? Well, this angle is A, this angle is 90. We can solve for this one again.
We have angle A plus 90 plus this mysterious angle, which we'll call M, equals 180, because it's the sum of three angles in a triangle. And so M will have to equal 90 minus A. How did I get this? I subtracted 90 from both sides, and I also subtracted A from both sides. So 180 minus 90 is 90, and then you have a minus A. So this is equal to 90 minus A.
And now we're up to our last angle that we need. What is this angle over here? When I was dealing with this triangle, I had an A, a 90-degree angle, and a 90 minus A, and it needed to add up to 180. Now over here, I have a 90-degree angle and a 90 minus A angle, just like I had in the triangle. And because all these angles lie on a straight line, they have to sum up to 180, just like in the triangle. So I have the 90 minus A, I have the 90-degree angle. I hope you can see that the only angle we're missing is actually an A. So this is going to be A. And you can prove the math out for that if you would like. So now that we've defined all these angles, it's time to go forward and solve for all these side lengths. I'm going to take a moment here and clear the board. Okay, now we're back. Now let's solve for these side lengths. Let's first solve for x. So we know, how are we going to get x? X is on the opposite side of A, so I know I'm going to have to use sine of A.
Is equal to opposite, which is x, divided by hypotenuse. And in this case, the hypotenuse isn't 1, it's cosine of b, divided by cosine of b. So you can solve for this by multiplying both sides by cosine of b. I'm not going to show it here because we're short on space, but if you multiply both sides by cosine of b, you get that x is equal to sine of a times cosine of b. I am just going to simply copy and paste that.
Okay, now let's solve for y.
Y is adjacent to a, so instead of using sine of a, I'm going to be using cosine of a. And as a result, cosine of a will be equal to y over cosine of b, because again, y is the adjacent, cosine of b is your hypotenuse. When you solve for this, you get y is equal to cosine a cosine b. This length over here is equal to cosine a multiplied by cosine of b. Now let's solve for the length L. L is associated with the angle A, and it's adjacent to it, so I'm going to say cosine of A is equal to L over this hypotenuse. Now this hypotenuse is sine of B, sine of B. So multiplying both sides by sine of B, we get L is equal to cosine of A sine of B. So L is cosine of A, and in blue, sine of B. Now let's solve for this E up here. That is an E, in fact. Maybe draw it. E. Let's solve for E. Well, we're going to use the same identity, only with sine. So I know that sine of A is equal to E over this length over here, which is sine of B. So multiplying both sides by sine of B, we get E is equal to sine of A times sine of B. So this over here is equal to sine of A, sine of B. Now we have two more sides to solve for. We're almost at the end. We have F and we have G. Let's first look at F, and I'm going to clear this space.
Now F is very special because it's adjacent to A plus B. So if I was to use cosine, because it's adjacent, it would be cosine of A plus B is equal to F, which is adjacent, over 1, because the hypotenuse for this triangle is 1. So F is just equal to cosine A plus cosine B. So this is cosine of A plus B. G will be sine of A plus B being equal to G over, again, the hypotenuse, which is 1. Dividing by 1 doesn't matter. So G is equal to sine of A plus B. And here's where the math gets really fun. Now that we've defined all our side lengths, we can look at this visually and get our proofs for cosine A plus B and sine A plus B. So let me clear the board one time, and are you ready to have your mind blown? Because we've constructed a rectangle here, we know that each parallel side has equal side lengths, otherwise it wouldn't be a rectangle. And we know it's a rectangle because we have 4 90-degree angles. And the only way you have 4 90-degree angles is if your parallel side, that'll be this side, and this side, and this side, and this side, are equal to each other. So let's first look at the vertical columns, these two over here. On this side, we have one side length, which is G, and G was sine of A plus B. So this was sine of A plus B. And what was that equal to? Well, let's look to the parallel side. We have L and we have X. X is sine A cosine B. Sine A cosine B. But it's not just that. It'll be that plus L, which is cosine of A sine of B. Cosine of A sine of B. And that's our first identity right there. Sine of A plus B is equal to sine A cosine B plus cosine A sine B. And I hope you can see that even as A and B change, as long as this rectangle's dimensions stay there, this side length will always be equal to this side length because we'll always be making this rectangle. So this statement will always hold true. But not just can we prove that, we can also prove what cosine A plus B is when we look to the horizontal sides. So over here on the bottom, we know that the bottom is equal to cosine A times cosine B. Cosine A times cosine B. Now what is that equal to? Let's look to the top side. We have F and we have E. F is equal to cosine A plus B. Cosine of A plus B. Plus sine A sine B. That's E over here. Sine A sine B. Now we just want to isolate this term. That's cosine A plus B. So I'm going to subtract sine A sine B from both sides. So in conclusion, you get that cosine of A plus B is equal to cosine A cosine B minus sine A sine B. And this is our second proof. And again, notice that A and B can vary, but no matter what A and B are, we can always create this rectangle. And because this rectangle exists, and it always can be created, the two parallel sides will be equal to each other, and the two horizontal sides will always be equal to each other. And therefore, both of these identities will remain true. I hope you now see that this trig identity can be seen in a visual way of a rectangle. Thank you for watching, and I'll see you next time.